Hello, and today what I want to do is introduce these little and remarkably affordable 1 to 5 voltage dividers and how you might use them. What I'm going to actually do with it today is I've actually got a PattonRobotics motherboard mounted here with a Teensy 3.1 on it, and I've got this 6-cell rechargeable pack which should be putting out somewhere between 7.2 and 8.4 depending on the state of charge, plugged directly into the board. Now, to explain a little bit on this side of the board, okay, over here where I have the output side of the 1 to 5 divider plugged in, I have it hooked up to pin A0 with the signal going to the innermost set of pins. The middle set of pins are capable of supplying voltage, either 3.3 or 5 volts. It's currently set at 5, so this red wire would be charged at 5 volts. And this outer set of pins is hooked up to the common ground, so the black wire is hooked up to ground. On this side of the board, I'm taking the input side of the 1 to 5 divider, and I have the ground hooked up to this brown wire, which is hooked to the outer set of pins on this side, and this red wire here with the little white jumper is hooked to the middle set. Okay, now on the PattonRobotics motherboard, it's possible to set the voltage on both sides of the board. This side of the board I can set between Vn and 5 volts, and this side I can set between 5 volts and 3.3. I have the jumper set at Vn, so that means the entire center set of pins is going to be the same voltage as the pack. Okay, so what I want to be able to do is I want to be able to measure the voltage of this pack while in active robotic competition or play, and make sure that my robot either indicates or shuts down or does whatever when the voltage drops too low. So to do that, we're going to go ahead and we're actually going to use a quick demonstration piece of code that's already preloaded. We're going to use in examples basics the analog read serial. Okay, I'll close this out because recall I have this hooked up. If you see here, I have it hooked up at A0. It's really kind of convenient. This particular example is already set for A0. Okay, the only thing I don't like about this example is it's set at a 1 millisecond interval, which makes the serial data scroll through so fast you can hardly see it. We're going to set it at 500 milliseconds or half a second, and let's see what we get. And I'll pause this while it loads. Alright, it's done uploading, and let's open up the serial window. And of course, currently right now we just got 1s and 0s. So now I'm going to turn on this side of the board where the power is hooked in, and we get a value of 523, 524, something like that. So what does that mean? Well, let's do a little bit of quick math here. If I take the value 524, all right, and I divide that by the resolution of the analog to digital conversion, which is 10 bits, and divide that by 1023, I end up finding out that the value of what did I put in, 524? 524 is a little over half the way up the scale. Okay, now the scale is between 0 and 3.3. The Teensy is a 3.3 volt device. So if I multiply that by 3.3, we end up finding that it turns out to be about 1.69 volts. Okay, now keep in mind we're pumping this through a 1 to 5 voltage divider. So if I multiply that number by 5, I end up finding out that I should be expecting about 8.45 volts. And let's go ahead and see what it's actually reading. I'll close that out. Close that out. I would expect something around 8.45. I'll move this out of the way. I'll just minimize it. All right. So I'm going to take and plug a jumper into this slot. This particular one is hooked up to the positive bus. This one is hooked up to the negative bus. And turn on my voltage, and we end up actually measuring 8.48 volts, so not bad at all. So let me actually do a quick little piece of code, and I'll come back and we'll make it so that it actually outputs the anticipated voltage, and we'll compare it one more time. I'll see you guys in just a few moments. I'm going to pause it. Okay, so I've added some little pieces of code to our existing code here. And the important things to realize is that I did in fact change the sensor value to a float. Makes the math a lot more stable. And then I put in the calculation exactly as I just did in the calculator. I divided it by 1023 because that's our 10-bit resolution. I multiplied it by 3.3 because that's the range of voltage that's capable of being read by the Teensy. And then I multiplied it by 5 because we're talking about a 1 to 5 voltage divider. I then output the data with a concatenated string, and you can see that it says that the input voltage is 8.42 volts. And once again, I'll move this out of the way. And if we look, and we'll compare it, and we find that it's actually 8.46, which I think is pretty good considering the tolerance of resistors and voltage dividers. So I'm pretty happy with it. I think it's working really well, and I hope you found this video to be useful, and I'll see you again soon.